Hello everyone. Today we're going to be talking about data visualization in the art of storytelling. We'll first begin with a roadmap of what this presentation will comprise. And we'll start off with defining data visualization and understanding its meaning. We'll also look into why this is important and why should we care. We'll move on to storytelling and visualization. What does it entail? What are the different aspects that are important in understanding this concept? These concepts? And then we'll look at certain basics in making effective and compelling visualizations. And we'll conclude with how big data plays a role in having a sort of a different understanding of uh, how simple visualizations can be expanded into when with the power of data, and what are we'll also explore certain tools that are important in this regard. So let's look at first, we'll look at what data visualization really is and try to understand its meaning. So I'll show you a few definitions and some quotations from important personalities that will help you unpack the meaning of visualization. So, Vice President of Marketing and Business Development at HP once said that visualization is being able to show people, not just tell people, not just show numbers or even show charts, but to have those charts and graphs and visualizations come alive. And I very much agree with what this person said, that it's not just being able to show charts and fancy graphics, but we need to be able to go deeper than that and derive a deeper meaning from that. And how do we do that? That's where the real question is. And that's what we want to learn here today. So a few other definitions that would help us understand this better. Visualization has also been defined as understanding and seeing, or trying to make our thoughts clear. We can also refer to as focusing on something or bringing focus to something. In other instances, visualization or to visualize has been referred to as constructing a visual image in the mind. And that's where we start looking into the importance of mind here, because that's where our visualizations or visuals are processed. So they're also referred to as graphical representation of data or concepts, and that's where our data part comes in. But before we delve into the data aspects of visualization, we would want to look at visualizations in general. So the question arises, why do we need to even visualize in the first place? Well, the simple answer is that people are good at scanning, recognizing, and remembering images. We'll look at a famous phrase in a few minutes that you might have heard very commonly, and it's called "pictures speak a thousand words," right? So if that's the case, why is it the case, and what does it mean for us in the data science world? So graphical elements also do other things which can be beneficial, and those other things include facilitating comparisons. And what do we mean by that? Well, when we show the differences in length, shape, orientation of whatever you want to present, the texture, even color, all those factors can help us make meaningful comparisons between one data set and the other, or between one variable or another variable within a data set, and so on. So extending that, we can notice that we have so many new techniques that can be utilized with the advancement of computing power, such as animation, which can show changes across time. But what really encompasses this, the overarching thing would be aesthetics. That means making something beautiful or pleasing to the eye, making something that looks nicer so that people would get attracted to it. So a very important quote that you see here is by Professor Ben Schneiderman. He's a professor of computer science at University of Maryland. And he rightly said that the purpose of visualization is insight, not pictures. And I want you to pay attention to this very important quote, that we're not just splashing or throwing around some text in a document and do some analysis and put some graphs and charts. That would be nice. But actually, what we're trying to do is dig deeper than that within the data and try to visualize it in a way that it would tell a story and not just show us some pictures, which may not be may not be meaningful in conveying a deeper meaning. Okay, so having looked at that, so we can understand that visualize is to form a mental image or vision of, or to imagine or remember as if actually seeing. So that's how the American Heritage Dictionary at a very basic level and the Oxford Dictionary define the word visualization or visualize. So what is information visualization? Let's take a step ahead. We just talked about basic visualization, and then when we connect it to data and talk about information and synthesis of that information, what does that mean? So we are actually saying that we want to transform the symbolic into geometric. That's one way to look at it. We can also say that we're using computer-supported tools, visual representations to basically amplify cognition. And the keywords here are amplifying cognition. We take out something simple, but we try to derive a deeper meaning through it and not only that, we can take a step ahead and from that data visualization, infer some other questions and deep and insights that we may not have thought about before. So a powerful interactive strategy for exploring data, especially when combined with statistical methods, is also referred to as information visualization by Schneiderman. We saw his code a couple of slides back. Okay, so why do we want to do data information visualization? Well, because it's very simple. We can, by looking at data, so you've already done exercises in Twitter data. You've done quite a few tutorials by downloading data, cleaning it, and trying to visualize it in certain tools that I had taught earlier in the semester. But analysts in every field can use interactive information visualization tools to look at faulty data, to identify misinformation, for example, to look at missing stuff, something unusual patterns that might emerge, some anomalies. So that's a very important aspect of why we would want to visualize information, because it could just give a very quick snapshot of what's going on within that wider data set that we have. And you can relate to that because of the kind of exercises that you've already done. So deeper and more thorough data analysis can provide more deeper insights, richer understandings, and then we can ask bolder questions based on those findings that we can get from there. So does it have a history? Yes, obviously. Just like any field, information visualization has been going on for a long time. Actually, some have even talked about the Egyptian civilization as being the first one to come up with certain images or visualizations of information in a meaningful form. It was very rudimentary at that time, but it advanced to the level that by the time we reached the 16th, 17th century, we started seeing something like what you see here, the bar chart, the classic way to visualize very simple data. And then that was William Playfair. He was believed to have developed the first bar chart in 1786, and that's quite interesting. And then today we've moved on to having all this happening in a very automated way. We have so many wonderful tools that can automate this process, and it's not as cumbersome as it used to be. So I referred to a very important word at the beginning of this presentation where I talked about how our mind is somewhat involved, or actually what was that exact word? I think I talked about the graphical concepts and how the mind plays a role in that. So when we talk about that, well, digging a little deeper, something related to a picture speaking 1,000 words, the human visual cortex, which is somewhere at the back of our brain, that dominates our perception of images and how we visualize things in our mind. Now, I would not be the uh, more deeper understanding of this is outside the purview of this course, but it's very good to know at least that a lot of this visual aspect starts from our brain. So there is a very interesting way to look at this, and that is using vision to think. So, I'll explain this as we move on. A graphic picture may be used to communicate a pre-existing idea or thought, right? So think about this. You see a picture somewhere. You might have a pre-existing idea about that. That picture might be able to advance our understanding of that idea, or it may strengthen what we already know, or it may change our perception about something that we already know or do not know. So graphical aids in different forms, or a simple picture even, can help us formulate ideas and thoughts, right? So vision can help us think and think about at a very basic level. When we look outside in the nature, we see the picture, like for example, the shape of a car, or a building, or a tree, or a mountain, and then we have certain ideas about what that texture would be like. How would it smell? Um, how would it feel? And all those sorts of things. And what is the size going to be like? So we already have something in our mind based on what we've been seeing since our childhood, or since the time we started paying attention to things. So there's this very interesting book by Stuart K. Card and those authors, including Ben Schneiderman, and it's called Information Visualization Using Vision to Think. And basically the idea in this book, which I would encourage if you're interested, it's really worth reading, is that they can amplify cognition by reducing time needed to search information. You look at something and you quickly know, okay, this must be it, or at least have a general idea of what's going on. You can increase your memory and processing based on certain visualizations, and you can also enhance detection of patterns. And that obviously comes through practice. The more you see these kind of visualizations, the better you get at it. But it's really worth looking into how visualization can amplify cognition. Okay, but it's really worth knowing that these are the three main factors or three main points that we can derive from this interesting book. Okay, so how do we know what we know is so? That's the starting part. That's where storytelling comes in. And storytelling and visualizations are very interdisciplinary. They're not siloed. They're not two different things. They're one and the same. So let's look at this chart. Dave Campbell provided this model of information refinement where, starting from some signal, we moved on to data, and now you can see we're moving into the data analytics part of this, having built the space and understanding this from a cognitive and a visualization aspects. So data is converted into information when we synthesize it. We move further, we change it into knowledge, and what we're actually coming at is insight. And that's where, through this, as you can notice on the horizontal axis, we have refine, and on the vertical axis, we have value. So the more refinement we have, the greater value we can derive from some piece of information, which in this case is going to be your data set, right? So moving on, your data gets refined so much so that we try to gain meaningful insight from it, but that takes effort. So why do we want to use visualization for storytelling? Firstly, comprehension is the most important thing. So brains process visuals faster than language, and this is proven through research. Seeing is believing, that's conventional wisdom, but we know that brains, when they look at visuals, we can process it much faster than if we tell somebody to say this or verbally. Secondly, retention. When you look at something, you're more likely to retain it or remember it or recall it later on. And that's why visuals are important. Thirdly, they are stimulating. You look at, and it's quite simple to understand. I mean, you look at a piece of text like this slide, It's not easy to remember, but if I have pictures for each and every word and try to associate things with them, they're going to be more stimulating, they're going to be more memorable, your mind is going to process them faster, and so on. And they're also very attractive to your audience, right? Because we need to sell our story. We just don't want to have a data dump and just show an Excel spreadsheet. We want to be moving a step ahead and try to come up with a chart. And the best example of that could be the sentiment analysis exercise or Senti strength that was done. And at the end, you came up with a chart, and look at what happened. So all these rows of, or maybe probably hundreds of rows of information, they were just +5, +4, -4, something like, the polarity of the sentiment, and then it came up in a chart format, which was so much easier to understand than the bigger data set that we have. Okay, so just a recap of what we just talked about. So visualization for storytelling, it helps aids comprehension, retention, and appeal. Now, let's move on to something very interesting and exciting. Let's step away from this stuff and go to Hollywood. There is a very interesting movie, which is one of my favorites. It's called Inception. I'm sure most of you have watched it. And a very important line from that movie is, what's the most resilient parasite? An idea. A single idea from the human mind can build cities. An idea can transform the world and rewrite all the rules. So thoughts are seeds. Now, those of you might not remember, just a brief recall of what was in that movie. Think about it. So it was about dreams, right? A dream within a dream. But then there was also about implanting an idea in somebody's mind so that they would change their behavior or their way of thinking. And that was a very profound message. And that kind of builds on what we are talking about here. So think about that. Where do my thoughts come from? That's a very important question. We may not even think about this because it's happening so unconsciously. When we were children, when somebody is implementing a new idea, or let's say you create a visualization. What makes you choose one chart over another? Where do your thoughts come from? What should your story look like? And at a very basic level, you might argue that, and rightly so, that you might be coming up with ideas and thoughts and different things based on your past experiences. So right from the time when you were a child, you've been seeing things, you've been experiencing things, and that's how you know what you know, right? Thoughts come from where? What is the central thing here? The brain. That's where the thoughts emerge. Okay, thoughts emerge from neural processes, and those neural processes come from everywhere. And there's this quote from an article in Forbes that, if you're interested, you could read. It talks about how our thoughts emerge, right? Well, it's a very complicated question, but for us in this topic of data visualization, this relates very much so because good data visualization comes from your past experiences, if we can say, your whatever aesthetics you have, and then again, one can argue your aesthetics are a product of how much training you might have, or how much of an artist you are, or how much gifted you are. Okay, and this relates to something important. Look at this picture. Let's say this is a Google headquarters in Silicon Valley. Why do you think design matters? I mean, why do you see? You might have heard of all the stuff about how their office space is so cool. It's such an ergonomic. It has wonderful furniture, and it's a nice working space. Well, what does that lead to? And why is that important? So think about the importance of design here. Does design help us be more creative? The way we have build our surroundings, does that contribute in any way to your creativity or what you would come up with in terms of different visualizations? So that's something to think about. Now, at a very small level, look at this number. It says 91%. It's in background red. It's in white, right? Very big figures. Now, if I could have done that at a very just write small 91% and that would be it. But then there is a difference. When you put something using colors and size and all those different things, you bring them in, it makes it more appealing. Like we said a few slides ago, what did we just talk about? It helps in stimulating your mind to think about something. And in the same way, look at this picture again. Does it stimulate your thinking about what kind of a place this is? Is it exciting? Is it useful? Is it out of the ordinary? Well, you might check mark all these 3 points. Yes, they are. Some may not find it that way, but a lot of people might be compelled to think about how effective design can play a role in making you think differently, in making you think more creatively. So this brings us to having built that understanding about the importance of mind, the importance of design, and the importance of space into all that we're going to be doing now. Where does the storytelling come in? Well, to understand storytelling, you have to think about this film strip, right? A film strip is what? It's an ordered sequence of events or different pictures that are joined together in a clearly defined path. So if anybody's edited videos, you know what we're talking about here, right? So what are the different basics of visualizations? Well, the information visualization process is very simple. You explore something. You might have to calculate certain numbers, but most importantly, you have to communicate it. And if needed, you have to decorate it. So these 4 different points sum up the whole information visualization process. Number 1, explore something, and that could be your data. Look at a data set. You might have to run certain numbers to calculate certain things, but then you don't stop there. You have to communicate it. And then in order to communicate it, in the 3rd and the 4th points are very related, like other points, you have to actually decorate it with use of colors, size, the choice of visualization that you're going to take. And then that's how you have to tell a story, and that's the basic of visualizations. So let me take you to some very important points that would help you come up with better visuals. Okay, so first of all, think about your message. Who is your audience? What is the purpose of your message? What is the tone that you're going to have? And in this case, that could be your color. What kind of content and this is going to determine the content that you have or the messaging. So keep your audience in mind. That's the most important thing. And because of that audience, depending on, let's say, your location, or if you have segmented the population according to where you're going to send this message, you can adapt the message accordingly. So thinking about your message is very important, number 1. Number 2, juxtapose image and text. Very important. As you can see here, this is a small snapshot of an analytics report. You can have charts, bar charts, line charts, but then you're also having text on the left hand. Then you have certain numbers that are bigger than the others. So big numbers kind of right away catch attention, just like the 91% I showed you. So when you're writing a report, you have to do all those things. And sorry for the typo there. So visualization should not be standalone. You have to weave it in a story. You have to guide the reader. So you start from the top, as you can notice here. Social media tips, and you're wondering what this is about. You have a 1.3 million potential reach, potential impressions, activity, contributors, and then you have those charts. So colors, annotations, titles, you see them there. Yes, but the most important thing is you are seeing visuals paired with text. So that's the second most important thing. Thirdly, you have to be consistent. So look at this chart. So for example, same axis, scale, same language, font, color, overall design or theme, again, sorry for the typo, design or theme, and that's how we can create a compelling design if we maintain consistency. So one more thing you notice here is color balancing, and that's a very important thing to do when you're designing presentations. So green here, green on top, green here. Similarly, you notice here, even in the slides, you have a yellow on the right-hand side to grab your attention, but then I didn't just put it there, you have it on the left as well. While we're at it, let me just fix the spellings here. All right. Okay, so 1, 2, 3. Number 1, think about the message. Number 2, juxtapose image and text, maintain consistency. And let's move on to number 4, which is redundancy. So what does that mean? Well, you do not want to repeat things, but at the same time, you want to be signposting in the whole document that you create or for some kind of presentation that you're going to make, some kind of analytics report that you have to come up with. So annotations are helpful, but you also don't want to be very repetitive. Next is the squint test. So can you squint at the graphic and still get the basic idea? That's the main thing here. So we don't want a graphic in which you keep looking and you're still wondering, what is this about? That's not a very effective way to deal with data. Moving on, we want to keep it simple. So by simple means, let's say if you want to do colors, you're more than welcome to do it. But if you have lesser colors, let's say you want to stick with 2, it might be a good thing because simplicity always wins. So overly embellishing something, whatever you're designing, can actually backfire because it might confuse the reader's mind into looking at all those colors and you're not sure what's happening. So you want to keep it simple. That's a good design principle. Avoid pie charts. Please avoid them. As nice as they look, as colorful as they are, people are not good at estimating angles. Look at it. Look at this chart. Okay, if we did not have these, the legend here or some kind of information next to the pie chart, it would be meaningless. I mean, how many people can even differentiate between these colors? What are the angles for them? And what does this mean? What percentage is this? Now, don't get me wrong, pie charts can be very important and impressive if you have 3 or 4 data points or 3 or 4 things that you want to show. So let's say if you have, let's say California here, Texas, New York, Florida, if that's all we have, then it might be a good idea. And you might want to report those numbers within the pie chart or something like this. It could work. But then if you have too many of them, why not do a bar chart or a line chart? So you see the point here that pie charts can be confusing. So it's better if you can avoid them altogether. But if you can use them wisely, then go for it. And lastly, you want to use color wisely. And that's quite obvious, right? So colors used strategically can bring the concept to life. Colors used strategically or used strategically can bring the concept to life, right? So here you might notice that there are limited choices of colors, and the way the combinations have been made, and a lot of tools make those combinations very well, but if they're not being made well, you might want to fix that color so that it looks appealing. Okay, so having talked about those important points, let's look at the goals of information visualization, and there are basically 5 different goals that we can think of. Number 1, make large data sets coherent. Present huge amounts of information compactly. Number 2, present information from various viewpoints. 3, present information at several levels of detail. And 4, support visual comparison. And finally, tell stories about the data. So this is basically the goal. And if I can say the overarching goal here is what? Storytelling, data storytelling, number 5. That's what we're doing. All the steps that we take, number 1, 2, 3, 4, are leading to that story that we're doing. And within that, you can also think about all the design principles that we just talked about. So there is this reading that has been posted online, and it's from Tableau. Which chart is right for you? And it lists through 13 different types of visualizations. I'm sure many of you would be familiar with a lot of these, like bar charts, line charts, pie charts, maps, scatter plots, Gantt charts, and so on. So common chart types, let's say, um, what does a line chart look like? It looks like this. Your scatter plots can be like that. Your bar charts can be like that, right? So these are very simple, common graph types that you would need to be using. But a line chart does what? It helps you make, um, uh, uh, well, of course, it shows you the x-axis and y-axis and where they meet. And it shows you the quantitative variables that are emerging from that analysis. A bar chart shows comparisons, smaller, bigger, and so on. Scatter plots show the relationship between two variables. Pie charts, we just looked at that a few minutes ago, emphasizing differences in proportion amongst a few members. Right? Pay attention to this: few members, not too many. So you have to be strategic in which chart you want to use. So getting back to this thing, and I'm sure I don't need to go into the detail for this because it's quite self-explanatory. You can look at it. The tools that you've been using till now and the one that you're using in the form of Tableau helps you make all those things. So it's very important to at least you don't have to learn this by heart, but just understand what kind of visualizations we can make and which ones are going to be compelling in telling an effective story. Okay, so big data visualization. Now we're reaching the end of this presentation. All this does what? Well, the problem is we have large data sets. How do we make sense of them, right? By now you already know you can have really large data sets. And the problem is we cannot read those Excel sheets. It would be very problematic to do that. So the solution is, now that you understand that we want to take advantage of what? Human perceptual system. Why? Because all those things. We remember those things, we retain that's stimulating and all those wonderful things. So you convert information into a graphical representation. That's what we want to do here. That's what information visualization is, right? However, there are problems. Yes, we have to deal with certain issues. How to convert abstract information into graphical form. Oftentimes you'll come across situations where it would not be easy for you to convert that into graphical form. Or there are choices and you have to make those choices. And you have to make that right choice. So do visualizations do a better job than other methods? Well, what are other methods? You can just show a screenshot of the data set. That doesn't work really well. If you have a small data, yes, it does, but you need to synthesize information and show it in some form of visualization. Okay, so are there some tools that can help us do that? Yes, there are. So data visualization tools are abundant. There are many. Learning them is a challenge because of the fluid nature of this field, data analytics. There are so many new things coming up every day. But the principle remains the same, right? So text analytics or analysis, we can do a sentiment analysis of Semantria or the one that you use, SentiStrength. We can even use Excel to our advantage. And then if we want to do forecasting or regressions or basic descriptive analysis, we can use SPSS. When we talk about network analytics, which we did, right? So we can use Gephi or we can use NodeXL. And we also use, remember what? Netlytic to do a basic network analysis. At this point, we're looking into visual analytics, and one of the powerful tools is Tableau, right? So you'll be watching, I'm sure you'll be watching the videos, the tutorials that can help you understand that, and you have an assignment on that. And then you also have something called Google Data Studios. Google it, Google Data Studio. It can help you display information in a very meaningful form, and I'm going to show you a few screenshots in a minute. And then you have location analytics. Now, when you're making any form of a map from a data set, that would be location analytics, and that can be done in Netlytic if you've got the location information. But a very advanced tool for doing that is ESRI's ArcGIS, and it's a wonderful tool for maps and spatial maps. Okay, so this is a network diagram or network chart for network users of Facebook from a data set that I had. And this is a social network analysis with Gephi. And you are familiar with this, right? Now, Tableau also helps you if you've got the location information. We have elements of location analytics in it. It can draw a map. And it can show which countries, let's say, had those tweets in a country. So this, for example, this data set had that. You can even dig deeper into that, so by a region within a country, and so on. You can show, let's say this is a simple line chart, and it shows tweet frequency. This has been generated with Tableau. So Tableau can do all these wonderful things. All right, moving on. So this is a screenshot of the Google Data Studio. What it does is it gives you a very beautiful form of report. So this is a nice way of displaying information. I'd like you to check it out, okay? And let me know if you have any questions related to this. And with this slide, we conclude our presentation for today, in which we learned about the basics of data visualization and some very important aspects that can help us make good visualizations. Thank you very much for your time, and please let me know if you have any questions. I'll be more than happy to answer them. Have a wonderful week ahead.